Yeah, she was singing.
Okay.
So
here's the deal, everyone.
It's been decomposing in my brain.
So, I'm teaching my pre-calc kids partial fraction decomposition today.
Yeah, we can ask them.
Well, you can ask them about it. Yeah, if you need help, phone a friend, right? What we are going to do is use partial fraction decomposition to help us evaluate an integral. Okay? So, for example, like if I gave you something like this, don't write it down. This is set up perfect for what?
Partial fraction.
Fraction division.
Complete the square. Simplification. Complete the square.
I like
What do you want? Use substitution. Oh.
Do you see how that's set up perfectly for it?
Yeah.
Oh my goodness, guys.
Okay. That's really where we should look first. Can I
So
use
it's the natural
substitution?
log of
Yeah.
radical u.
Doing the list of this like.
Now, if I change one number,
Oh boy.
Integration.
we no longer can do that. But that doesn't seem like an integral that should be impossible. Because it's not.
We can just do all our tricks. Do the sine x thing. Do the sine.
Oh,
thing.
not with that. That's not going to help.
It would help a little bit.
Okay? So any fraction can be decomposed to the sum of individual fractions, right? Or we can take a fraction and whatever's in the denominator, we can say, okay, here are my factors, and for each factor in the denominator, we have a fraction that we could add together, right? It's essentially, do you remember when you try to get common denominators to add fractions together?
Yeah.
We're going the other way. We're taking something that's been added together and we're breaking it apart. Okay? So essentially what we're going to do today, I'm going to throw an integral in front of a problem that I can give my pre-calc kids. That's not saying like you should be able to do this right now. Okay, we're going to have to review it. Like I understand that. It has been exactly 2 years since you've done this.
Yeah.
To the day. But once we do the partial fraction decomposition, the integration's the easy part. Okay? So
Can I write this one down?
write this one down. Okay? As I said before, look for basic rules. Oh, I'm sorry, this is 8.5. Partial fraction decomposition. I would just put PFD. Because that's a lot of letters to write. The partial fraction, not the PFD.
Fun fact, I work in a Chinese restaurant and PFD stands for pot stickers when they write our tickets. So it's what my mind like automatically went to. I'm like, no, that's not right.
Math is way better than pot stickers.
I disagree immensely.
Oh, what did I forget?
Is math class just a sitcom now?
Okay.
Oh,
Do we have a basic rule that this fits?
I
not
wish.
really.
If we let you, second thing that we look for, okay, I see that there's a quadratic in the denominator
Can we find
and a linear upstairs. So like if I let u equal x squared plus 3x minus 10, does du equal 8x plus 82?
No.
Not even a little bit. So, what did you say? Can we factor? Yeah.
I wish.
So we're going to take this. I'm going to stop writing the integral for a moment. 8x plus 82. 82, that seems excessive. What is our denominator factor to?
X plus 5 times x minus 2.
Okay, so let me remind you of what you did 2 years ago on this day.
It was like A over.
Way back Wednesday. See, this is the way back Wednesday.
Oh.
Okay. What did you say it was?
Isn't it like A over X plus 5 plus B over X minus 2?
Yes. Okay. Since we have 2 factors in our denominator, we can break up our fraction into the sum of 2 fractions, each with a unique denominator coming from those factors. Okay. So now our goal would be to figure out what A and B are.
And that's like when you do like the cross multiplying and then set 1 equal to 0 to find 1, right?
Well, I wouldn't call it cross multiplying. The method that we talked about 2 years ago was multiplying both sides by the common denominator.
But basically, it's like cross multiplying.
It is cross multiplication.
That's exactly. One of them cancels out. It's just like-
Cross multiplication
That's my educated.
is this: 2y equals 3x.
Exactly what you're
No!
I mean,
No, this is distributing. Let's distribute. And when we distribute our LCD to this guy, we're left with 8x plus 82. When we distribute our LCD to this guy, we're left with a times x minus 2. Because we get some factors that cancel. And when we take the LCD to this third fraction, we get b times x plus 5, because the x minus 2's cancel out.
I remember being really good at this.
Good.
I don't.
Hey, and you know what? Whether you are good at it or not,
oh, maybe just get a system of equations,
well, we can do a couple different things.
Well, can't you fix what x equals figure it out for one of the letters?
Yes, there's 2 different ways we can go about this. If we have linear denominators like we do here, this is the easiest way. What would make this go to 0?
2.
So if we plug in x equals 2, then we have 16 plus 82.
Minus 8.
What?
Don't I have it as
Oh,
plus?
it's plus.
Oh,
Yeah,
okay.
I've been writing.
Okay, we would have 98
Wow.
equals,
That's
no. I'm right.
98 equals 70.
16 plus 82.
no, that was 98.
So B is 98, 7.
What's a times 0?
0.
Equals,
B 70.
What's 70? What's 84? It's like 14, 16.
What?
Yeah, it's like 70.
oh, that's actually a number, isn't
That's
it?
what, that's what I was saying.
What is it?
I think it's 14.
It is 14.
98 divided by 7 is 14.
Yeah. If you don't believe me, you can do it.
That's where it's 14. Oh,
Okay, what's another number we could throw in?
5. Negative 5.
If x equals negative 5, we would have 42 equals negative 7a plus 0, which means a is negative 6. So what have we done?
we've solved it.
We've done partial fraction decomposition.
Wait, what if it's not linear?
X equals
So we
40.
took the integral of 8x plus 82 over x squared plus 3x minus 10 dx. And it is now the integral of a over
Yeah.
x plus 5 plus b over x minus 2 dx.
That looks pretty good.
Yeah,
It
seems
does.
doable, I guess.
Because if we have 1 over x, Darby, what's our antiderivative?
Natural log.
Of?
The absolute value of your stuff.
Okay.
Plus C, plus C.
So if we have this linear denominator here, The antiderivative of 1 over x is natural log of the absolute value of x. So the antiderivative of 1 over x plus 5 is the natural log of the absolute value of x plus 5. So we have negative 6 natural log x plus 5 plus 14 natural log x minus 2 plus c. Good.
You know, I like this a lot better than trivia identities.
Yeah, me too. No,
Yeah.
something's gonna get thrown in there.
Yeah, but like in a
Something's gonna
week
get
from
thrown.
now when we're about to take the test, like a week minus 2 days, and you really how to do trick stuff.
Where do you get a week minus 2 days?
Integrals of
It's on
week.
like
Test
Tuesday,
is-
isn't it?
It's
Isn't it
November
how it
6th.
links? Oh, November 6th? Yeah, we have an entire, like, 2 more sections to do, right?
Yeah.
Yeah, we have.
This goal. This
We
is
have
like
another
almost a
quiz.
month. This
Mhm.
chapter is almost a month worth of learning.
I don't
Better
really see
girls.
much related in this chapter, like the first 2 parts.
I feel like we're just like
It's always
getting a bunch of integration tricks,
and then we're gonna apply them later.
and then like, and then we have to go fight the final boss, which is just like a monster integral with like, and then we have to do like all the things, and then we win, and then we win calculus.
Just look.
I'm
You still
pretty
have
excited
Calc
for that.
3 differential equations to get through.
Yeah, I'm sure.
You guys are all, like, switching. What's going on?
Oh, we're looking at how much space I took up, and Amy goes, she wrote, and then she goes, new page, and I was like, how?
That's literally not possible.
Amy has, like, really big, dark handwriting.
What, like me?
Yes.
Yes.
You do too. Yes.
I have like
You both are grouped together in the handwriting. And then Gabe has, like, the teeny tiniest, lightest handwriting. Like, I have to, like,
Can I see
squint.
can I see your handwriting?
man,
Am I right?
my notes are not like
I mean, that's kind of like
see
mine,
that's
but mine's
normal
like darker.
though.
Well, if
That's
there's a
what's
few.
going on.
That's like, I do
Okay, what's different about this guy here?
The denominator is the same, like x plus 2, x plus 2.
Okay, do you see how we have
That means
our
we-
denominator's factored, but it's like repeated?
Yeah.
Okay, there's a trick to that.
Oh.
So first of all, do you see how this doesn't follow a rule?
Yeah.
Yes.
You see that U substitution is just not even on our radar with this one. Like, no, it's not going to work. Okay? But we have a fraction that involves polynomial numerator, polynomial denominator. Our denominator factors nicely. So we can take this and we can decompose it. It sounds strange, but
But we only decompose it partially. Only partially.
only partially.
It's like a
How-
zombie, but like a really fresh zombie.
I have a
Stop. Stop.
How many fractions are we going to add together?
Probably
2?
Two, because there are
2 terms.
two factors is what I would say. All right, but here's the deal.
Uh-oh.
If we write this right here,
You get A plus B.
okay, so we can't do that, right? Anytime you have a repeated factor, you have to represent each of the exponents.
I think I remember that.
So if this was x plus 2, the quantity cubed, you would have a over x plus 2 plus b over x plus 2 squared plus c over x plus 2 cubed.
I do have a question.
Yes.
You know, when we were, like, this is like semi off topic, semi not off topic. When you have like u equals whatever, and then it didn't completely take care of the x, and then you just solve x for u and
Yes.
then put it back in there.
Yes.
Can't you do that there, or is that not a thing?
Put that thing back.
Because like we never used it again. Like
Yeah.
Oh,
You
it's-
probably
it's just not your best option.
could, but it's gonna be real
Not
ugly.
fun.
I have a question.
Real ugly. Yes.
What if you have in your denominator something to the 27, and you run out of letters? Where do you go from there?
Double A.
That's boring.
Yeah, you can start using some Greek letters.
Oh my goodness. You should get one of those things that Mr. Marsh has, a Greek alphabet.
alpha, theta,
That's
linear.
the alphabet
I
of
like to
physics.
stare at it and
All
make up
three.
fraternity and sorority names. when
Alpha,
Very
theta.
I do actually beta, eta, theta.
Yeah.
I don't know if Beta, eta, theta.
Okay, how do you pronounce PHI?
Beta, eta.
It depends. It's either phi or phi depending on what it's after. You guys did that in unison there. I'm just like, okay, let's continue. Let's continue. There's a full moon and I can tell. There's a full moon.
Is there? There is! I saw them in last
It's starting.
What was that?
Is everyone okay with my work until here?
Yes.
I really hope I am not gone on the stage next year. What should we throw in for X?
Negative
Four.
2.
Who said 4?
I don't know.
Did you tell me why you said 4?
No, I was trying to think of like. No, I don't know. I had something else because you
4.
want A is the only thing that has X, so you need something eventually to get to 6.
So let's save your 4.
Okay.
Save your 4.
Okay.
For right now, can we do negative 2?
Yeah.
And we chose negative 2 because what?
It'll cancel out A.
It'll zero out this factor. So 6 times negative 2 is negative 12, plus 7 is negative 5,
It's,
Oh.
That's B.
equals B. Okay? At this point, Jackson's point was B doesn't have an X term on it. So we're going to find B, but then we have no way to zero it out.
Can I just put negative 5 in for B?
We have what B equals.
Yes,
Oh wait, you can.
but we don't know A. Yeah, we know that B is negative 5, but we still have A to figure out. So he threw out a random number.
Oh, yeah.
4, was it? We can plug anything in for X. We know B is negative 5, and now we have just A left over.
Well,
right?
you can
Set-
put in
just
What
any
do you
set
X
X
just
equal
do
to
0
That's
then?
what I'm saying.
I feel like 0 is an easier number.
You do 0, I'll do 4 with Jackson, and we will see what we come up with.
A
Oh, do
equals
it.
6. Problem solved.
You can't do because there's no X. You do.
No, but you can just pick X equals 0, and then you just have 7 equals. Oh, wait, that would. Then you would just
No,
have
because-
2A minus 5.
8
7
equals
equals
6.
2A minus 5. So then 2A
So
equals
12
12,
equals
and
2A
then
is
A
6.
equals 6. That made sense in my head.
Did you get A equals 6?
Yes.
Oh.
And you plugged in a different number than me?
Yeah, so 7 equals 2A plus, or minus 5, then 2A equals 12, and then 2 equals 6.
Alright, so what do? We took the integral of 6x plus 7 over x plus 2, the quantity squared, dx, and we decomposed that fraction, partially, right, to get 6 over x plus 2 minus 5 over x plus 2, the quantity squared.
This has been reversed.
Okay, please do not be this person.
The natural log of x plus 2 squared.
Don't be that person. Because that's not what the antiderivative is. How did you know that that's what I was thinking?
Because I thought it for like
Yeah.
I thought it for like 1 second, and I'm like, that's not how it works.
Okay? Side note, this is the integral of negative 5 times x plus 2 to the negative second power. Right? We need to use which rule?
Power rule.
Okay, so this becomes x plus 2 to the negative first multiplied by, or divided by negative 1. Let's see. And I know it's so tempting to just be like, we use partial fraction decomposition, natural log, natural log, natural log.
Natural
You get a
log.
natural log, and you
Natural log of
Pro
x.
except for you.
Oh no.
Yeah.
Ben Franklin.
All right,
I think we need any
let's step it up a notch.
It was 5
Okay, what's different about this one?
It's a cubic.
Oh.
She is crunchy.
It almost looks like the taste.
Chips are crunchy. I don't.
Math can be crunchy too.
Okay,
Crunchy.
so can x squared plus 2 be factored anymore?
No, not with
Not with real numbers, and we like to live in the
real
real
numbers.
realm.
One of the questions on our, what do you call it, our practical thing at UNO was how to do a bunch of imaginary stuff.
Oh yeah.
Nobody uses imaginary.
Okay, so we have 2 factors. I know that our denominator is cubic, but we only have 2 factors. So we're still going to break it up into 2 fractions. However, if we have a quadratic factor, as we do here, we need to have a linear numerator.
Oh.
Oh boy.
See,
C.
let's see. I feel like we did this in algebra 2. I feel like this.
Definitely pre-calc.
Okay. It just feels like a wriggle room thing. I feel like I had a window.
I feel like there are windows inside.
That window is always closed.
There are
You
windows.
never get any light.
I feel like it only
Well,
is
because
that
people
window-
complain about it reflecting on it.
It only is that window.
Okay, guys, we're almost out of time. Let's keep going here.
Let's do it.
It is Wednesday. We do have like.
It is Wednesday.
Like 14.
Yeah, that sounds about right.
Okay. Are you okay with why I chose bx plus c in the numerator? Because we have a quadratic denominator, linear numerator. I'm multiplying by the LCD. Yes.
So, like, if you did a bx plus c for the x plus 2 squared, because technically that's quadratic too, you just end up with b equaling 0.
Like back to this.
Back to the other one.
Okay, so here is a big difference. This is still considered a linear factor.
Okay.
I know that the denominator is quadratic, but it's a linear factor, and that's what
Okay.
matters. Do not.
Yeah.
I don't think it'll work out right if you try to do that.
Okay.
Okay. I mean, yeah, maybe. I mean, you should get 0, but you're creating a lot of extra work for yourself.
Yeah.
Okay. So linear factor, even though it's quadratic factor for our denominator. Okay. That is a good point to make. Thank you. All right. Now, here's the issue, though. We can plug 0 in for x and be able to solve for a,
Yeah.
but then we're kind of toast for b and c.
Linear.
So this is what we're going to have to do here.
So A is 1.
I multiplied that out. Why did I do that? Well, whatever we have on the left should equal whatever we have on the right. Do you agree?
Yeah.
Okay. So, if I add ax squared plus bx squared together,
Well, they're both constants.
You should get 0.
you should get 0. Do you see an x squared over here? No. So those a and b need to cancel out. A plus b better equal 0.
Why?
Because there's no x squared term over here. If these two equations are equal, then ax squared plus bx squared needs to equal whatever the x squared is over here.
But that would have to make, that would also make C 0 because A is equivalent to 1/2, making 2A equivalent to 1.
Well, you're kind of a step ahead of me here. C, is there an x term over here?
No.
So C better equal 0. And 2A should equal 1 because they're the constants. So you're right, A is 1/2.
B is
C is 0, so yep, B is negative 1/2. Okay, and technically you could do this with any of the problems. You just could get a 3-variable system with 3 equations that have all 3 parts in every equation, and then you have a lot of algebra to solve. So if you have linear factors, I would really encourage you to use that zero out method that we were talking about, because it's a lot quicker than having to do all of this algebra.
Are we gonna go to qubits or?
Oh, thank goodness.
Okay, so what we have, the integral of x over x times x squared plus 2 dx becomes the integral, let's see, we have 1/2 over x.
Well, it's not 1
Well,
over
wouldn't that
x.
just be 1/2x?
Yes. Either way is fine. Is it okay that I just keep it like this for right now?
Yeah.
I'm just
Yeah.
really making a point, okay? Plus negative 1/2 over x squared plus 2.
Well, it's negative
Yes.
1/2 x.
Yeah, because that was the b, and then there's no c.
Yeah.
All right, so let's just make our lives a little bit easier. Can we do that? Can we write this as 1/2 the integral of 1 over x dx minus 1/2 the integral of x over x squared plus 2 dx? Can we do that? Okay. I got that one.
Well, you could factor out another 1/2 because you can do u substitution.
Okay, the second one we're going to have to do u substitution for, right? U is going to equal our denominator. Du is going to have to equal 2x dx. Okay, well here's x dx, and we need a 2x dx. So you're right, this is going to become 1/4 integral of 1 over u du. So we end up with minus,
Minus 1/4 from natural log of x squared plus 2.
The C comes back.
And if you don't want to use the letter C in your partial fraction decomposition because it confuses you with this C, that's okay. You can choose whatever letters you want. If you choose
Except x. Don't use x.
that would be silly. If you want to use,
Can I use triangle and circle?
J.
I mean,
J. So
I would not use circle because it looks like 0.
But
Okay.
I can use triangle. Triangle is
Delta.
You could.
Use it.
because it's math.
Use
math.
delta. That's a triangle.
You know,
Yeah.
welcome to real numbers, man.
I know,
I
right?
thought this would get
Okay,
us-
thoughts about this.
I
Thoughts about
thought it
this.
was gonna get
Is it coming back to you?
yeah.
That's
Yeah.
pretty straightforward.
Okay, I like it. I think out of all the things that we've done, I mean, I think integration by parts, I think, is straightforward, and if you can use the chart. Otherwise, it gets a little bit,
Yeah.
you know, you have to finagle a little bit. This is, I mean, you can either do it or you can't, right? I want to kind of give you an update as far as the rest of the chapter, and Darby has her gold sheet out, and so this makes it really nice. So tomorrow, it's a freaking weekend after tomorrow, and so instead of splitting up 8-7 and 8-8, we're going to take a day, and I'm going to give you a worksheet where you get to use all of these techniques to solve problems from like chapter 7 or from before, okay? So I'm going to give you some instances where you could use this to actually solve for something, like whether it be a centroid or a volume or an area or anything like that. Next week, we're going to learn, we're going to revisit L'Hopital's rule and look at the cases where you have like 1 to infinity or things like that. And then we're gonna look at improper integrals. Improper integrals occur when you have like the integral from 1 to infinity, or you have the integral where one of your limits of integration makes your function undefined. Like,
Oh.
okay,
Undefined function.
1 is an asymptote, but I'm giving it to you as a limit of integration.
Rude.
Okay, so we're gonna look at integrals like that on what day? Tuesday. Okay.
Hey Darby, could you send me a picture?
I'll send